Okay, in this example we're asked to find the critical values, domain endpoints and extreme values, both absolute and local, for the function y equals x, square root of 4 minus x squared. Right, so the key element to this is to find the extreme values, absolute and local, and to do that we're going to need the domain endpoints and we're going to need the critical values. Right, so let's begin and by first of all finding the domain endpoints. Right, you'll notice that in this case here, this function here is dictated by this square root sign, and we know that in fact the 4 minus the x squared must be greater than or equal to 0. So this will imply that 4 is greater than or equal to x squared, or x squared is less than or equal to 4, which of course implies that x is less than or equal to 2 or greater than or equal to negative 2. This means that the domain here for this function, alright, is negative 2 to 2. Okay, the endpoints of course being negative 2 and 2. Alright, so we've done that. Now the next thing we're going to need to look at is the critical points. Now critical points occur when one of two things happen, or where both things happen, and that is, number one, the first derivative is equal to 0, or the first derivative is undefined. So we're going to have to look for both cases to see when this occurs. Right, so let's begin. The first thing I do is I say, let's say that y can be written here as 4 minus x squared to the half power. So the first thing I do is I write this in terms of exponents. So consequently, when I do dy on dx, it's going to involve the product rule, because I've got the product of two functions, and this second function is a function of a function. It's 4 minus x squared to the power of the half function there, a power of half or square root function. And so we're going to need to do the quotient rule, the chain rule, alright, on this second function. So let's begin. Derivative of x, of course, it would be 1. Multiply it by the second function, plus the first function by the derivative now of the second function, which of course we bring the half down, 4 minus x squared. We take a half, 1 off the half, so we end up with negative a half, and now we do the inside function, which will be negative 2x. So that is the derivative, and of course this will become 4 minus x squared to the half minus, the 2's will cancel, x squared over 4 minus x squared to the half. Now tidying this up with a common denominator will lead us to 4 minus x squared to the half will be the common denominator, and we're going to have to multiply this one by this one. Alright, so we're going to need a 4 minus x squared, and we're subtracting an x squared. And at the end of the day, therefore, our derivative is 4 minus 2x squared all over the square root of 4 minus x squared. Right, so this is our derivative. Now, let me rearrange my pages and let's see what else we need to do here. Now you'll notice that if we come back here, here's our derivative. dy on dx. Now remember that critical values occur, notice here, when the first derivative is 0 or it's undefined. Okay, first thing we notice is that this is clearly going to be undefined when x is going to be 2 or negative 2. So we've got two critical values. Right, so let's write these critical values down. Right, so critical values. Right, dy on dx is undefined when x equals negative 2 and 2. That's the first thing. And of course that's because when I put 2 or negative 2 here for x, I get 0 on the denominator, which we can't have. Right, next we have to look at dy on dx is equal to 0 when, alright, 4 minus 2x squared over the square root of 4 minus x squared equals 0. Now you can see clearly that this has nothing to do with the denominator, but has everything to do with the numerator. And this will be when 4 minus 2x squared equals 0, or when x squared is equal to, or 2x squared is equal to 4, or x squared is equal to 2, implying that x is equal to the square root of 2 and the negative square root of 2. So in other words, we have 4 critical values. So let's write those down. Critical points. Right, critical points are going to be negative 2, 2, negative root 2, and root 2. Right, now this is what I do. Now notice that the derivative is not defined at negative 2 and 2. And so what I do is I draw a number line like this. And of course here's 0. Let's suppose here's negative 2. I'll put a broken line because we're not allowed to have that negative 2, and a broken line for 2. And then of course here's 1. Here's negative 1, so square root of 2 is approximately 1.4, so we end up with here and here. Okay. Alright, so this here then is the negative square root of 2, and this is the square root of 2. Now what we want to know is what happens to the derivative in these different sections of the number line. We don't have to worry about outside of negative